Today we're going to learn about exponential growth and decay models. We're still using exponential equations, but now we just have new words to describe the equations. Previously, we've seen that if our multiplier is less than 1, we call it a decreasing function. That's where the amount in the account is actually decreasing over time, becoming less over time. The new word that we can use to describe that would be decay. A decay model. Decay and decreasing both mean the amount in the account is getting smaller over time. We've also seen that if our multiplier is greater than 1, we can call it an increasing function. The new word that we can use is growth. An increasing function and a growth model all mean that the amount in the account is increasing or getting larger over time. A decay model, if we look at our graphs, a decay model or a decreasing model has a negative slope. It is slanted down if you read it from left to right. Or as the x's get bigger, the y's get smaller. A growth model has a positive slope. Whereas you read it from left to right, it's going up. Or as the x's get bigger, the y's are also getting bigger. Let's take a look at some examples. Example 1, a new car is purchased for $21,100. The value of the car depreciates, meaning decreases, at 10.5% per year. What will the value of the car be after 6 years? So let's define our variables. X is going to be our number of years because our interest rate, our depreciation rate was in years, and Y will be the value of the car. Let's write our equation. Y equals A times B to the X. A is our initial value, and we initially had a car value of $21,100. Now our multiplier comes from the interest rate, the depreciation rate. Initially we had 100% of our car's value, and then we lost 10.5%, which means we now only have 89.5% of our car's value. To actually write this number in our equation, I need to write it as a decimal. So to write it as a decimal, you move the decimal place 2 spaces to the left. So I'll write it as 0.895, and I won't write the percent symbol because now it's a decimal. And there you have it. That is our equation that models the value of the car over X number of years. And to figure out how much the car is worth after 6 years, we're going to plug a 6 in for X. We put that in the calculator and see that after 6 years, our car is worth $10,844.78. It told me to round to the nearest cent, so I went out 2 decimal places because that's how far out cents go. Let's take a look at example number 2. $3,400 is placed in an account with an annual interest rate of 7.5%. How much will be in the account after 17 years? Annual interest rate typically means the value of the account is increasing. So let's define my variables. X is going to be the number of years, because annual means yearly, and Y equals the amount in the account. So let's write our equation. Y equals A times B to the X, where my initial value is $3,400 because that's the original amount placed in the account. And now my account is increasing. So I initially had 100% of my account value, and then I received an additional 7.5%. So the following year I'll actually have 107.5% of my original account value. And that will continue for each year. So to write that as a decimal, it would be 1.075. Remember, the account value is increasing, so our B needs to be greater than 1. That's why for these growth equations, you'll end up with a B value greater than 1. Now, if I want to figure out how much the account is worth after 17 years, I'm going to plug a 17 in for X, put it in the calculator, and I see after 17 years, there's now $11,625.80 in the account.